So, we've been dealing with expanding sets of two brackets. We call these binomials, but I'm not that caught up in the terminology. We'll come back to that. What we've been doing is using what I call crab clause to expand our brackets, correct? So if I wanted to deal with this, I'd apply crab clause, like so. And that would give me what? Thanks, Jack? Jack Atwood?
2x.
Well, what happens? What's x times x, which is x
squared
plus?
Just 1x.
Yep. Plus?
Plus
This one here?
x 4x.
Yep. Plus?
Just 1x.
No, I've done that one.
Oh, 4.
Yeah, plus 4. And then I collect my like terms and I get x squared plus 5x plus 4. We're reasonably good at that, correct? We've said that before. What we're going to look at today is doing the reverse. So how do I go from this back to that? And we're going to give you a few steps to follow. So I'll put up a little midsection here with the steps. Step 1. So if I want to turn, give me some numbers here. X squared plus 8x plus, I can't do 1, I can't do 6.
3.
I can do 15, let's do 15. So I want to do that. Step 1. I'll show you in a second. Step 1, I need to draw my brackets. What else do you think I already know what I need to do? What do I already know about this? Right, that's a bit clearer. Sorry. So I've got x squared plus 8x plus 15 equals, I've drawn my brackets. I'm going to tell you the term that it relates, well, James practically knows, but it relates to this term here. James, what do you think it is?
X.
X. I know that my first two terms are going to be x, don't I? How do I know that?
X squared.
That's the only way I'm going to get x squared, isn't it? Is having x times x. Does that make sense? So brackets and first terms. That's my first step. Step 2. What do you think the next step would be? Alright. What can you tell me about the numbers on the what do you think you can tell me with certainty about the numbers, because there are going to be numbers in there. I want you to think about what you can tell me with certainty about those numbers. Do you know what the numbers are? Do you know what they are? You don't know. Should you know what they are right now? No. So do you know what the numbers are? What can you tell me about them though? There's something you do know about these numbers.
There's going to be a plus.
They're both going to be positive. How do you know they're both going to be positive? So there is a way you know they're both going to be positive. How do I know that both numbers are positive?
Addition.
Yeah, I've got two positives here. How do I get that number? How do I get the 15? How do I get the 4 before? How is that created?
4 times 1.
4 times 1, correct? If one of those numbers was negative, what would happen? Would it be plus 4 or minus 4?
Minus 4.
Minus 4. Because we've got a plus there, there's only two ways we can multiply a number together and get a positive. What are they? We can multiply two positives or
2 negatives.
two negatives. But if I look at this, so I could have two negatives, couldn't I? I could have two negatives. How do I know? I'm dealing with two positives though?
Plus sign.
This plus sign. How do I get that? How did I get the 5x before? How did that come about? I had
4x.
4x and?
1x.
And I added them together, correct? So the next step is the sign. You'll get better with that, just trust me. There's a bit to take on. Step 3. What I want you to do is write down the factors of the last number, or the constant factors of the number. So what's the number at the back that I want us to find the factors of? In this example, what are the numbers?
8.
No, just the number.
15.
I want you to find the factors of 15. So write down the factors of 15.
3 and 4.
There's heaps. There's a few. So once I've found my factors, I need to identify the set of factors that can add to make this number. So let's go back to this example here. What are the factors of 4?
2.
2 and 2, or
1.
1 and 4. What of those factors add to give us 5? 1 and 4, correct? So, in this example, what are the factors of 15? We've got 15 and 1 and 3 and 5. What combination of those factors adds to give me 8?
3 and 4.
3 and 5, guess what we've done?
And then
Found their numbers. How could I check? How could I check that this works? So factors, step 3 was factors. What was my step 4? I missed that. Sorry, I didn't write it down. What was my 4th step? What do I need to do with those factors? Yeah, and I need to check they add to my what term? Second term. So I need to check that they add to my second term. Are we good with that? Now, how could I check that this is the right answer? How could I check? Because I haven't mastered graphing and I can't use all those wonderful skills that I've got. How could I check that this is the right value? We're doing the reverse of this, aren't we?
Yeah.
So if I expand these brackets, what should I see? I should get that. So let's check. X plus 3. Oh, that's not going to be right. 3. X plus 3. X plus 5. I apply my crab clause. And I get x squared plus 3. Sorry, it's not right. Plus 5x. Plus 3x plus 15. I collect my like terms and I get x squared plus 8x plus 15. Does that match?
Yeah.
So I factorise correctly. Cool. It does get a bit tricky when we add minus signs in there. We're going to get our head around the idea with all positives today. It's just be all positives, and then we'll introduce the negatives later on. But if you can grasp that process, you're 95% of the way there. So let's get some examples up. Who thinks they can give me some numbers that work? X squared,
4 and 4.
x squared
7.
plus 7x.
Yeah.
Okay, so I need, what's the number that could work? 14 won't work?
3.
No?
12. 1, 7.
12 will work. Hold on. 12 will work. B, give me another one. X squared plus 9x plus
18.
18. Very good, that works. We see in a pattern?
Yeah.
Okay, let's go. Have a go at those.
Yeah.